We've been going through C++ programming. In short, we are still on programming languages. And I've come up with this diagram which may help us fully understand where we are. Assuming this is a program we want to run. We have written this program, and this program can be written either in machine language, assembly language, or a high-level language. When you write one in machine language, it simply means you have written a program in a native language of a computer. Computers, as we know, they understand binary languages. And when you write a program in binary, that program is direct in the language of the computer. And there is no need to translate that language because it's already in a native language of a machine. Any machine language is written in binary. And since it's in the native language of a computer, we say it is in the first generation language. Apart from machine languages, which are written in binary languages, we've got what we call assembly languages. Assembly languages, they use symbols. Like in this diagram, I've used ADD, XY as symbols to represent a program. And assembly language are next to machine language. They are in between machine language and the human languages. So we call these as the second generation languages. And for this language to run on a computer, as long as it has been written in assembly language, it is supposed to be converted to the language a computer understands, which is machine language. So we need a program known as an assembler. This assembler language converts the assembly level language into a machine level language. After conversion, the resultant program is what will be able to run on a computer. So assembler language cannot run on a computer unless converted to the language the computer can understand. And that's where an assembler language comes in. The other level of programming we can do is high-level language. And high-level language are the third generation. The first generation there, we've got machine level. Second, we've got assembly level. And finally, we've got the high-level language, which are the third generation languages. High-level languages, they favor human beings, which simply means they are easier understood by humans than a machine. So for high-level language to run on any machine, they first need to be converted into machine languages, either by the interpreter or the compiler. An interpreter is a program which converts the high-level language into machine language line by line, or if you've got possibly 5 statements in your program, it's going to convert or interpret, translate it into binary language statement by statement, line by line. When one statement is translated, it will go into machine language, and there it will be executed on a computer. Then the next instruction will be interpreted, and there it will be interpreted, it will be run on a computer, it will be executed. Then the other form of converting a high-level language into machine language, we've got what we call a compiler. A compiler is responsible for translating the entire program written in high-level language. And after the program is converted, that's when it will be able to run on a machine language. So When we talk of interpreter, it converts line by line. When we talk of compiler, it converts the entire program written in high-level language into machine language. So, what we need to know about programming languages is that when a programmer writes a computer program, first of all, that original program written by a programmer, we call it a source code. A source code cannot run on a computer. It's supposed to be converted to machine language. And there are two types of source codes we have in the screenshot here. We've got an assembly language and a high-level language. All these are source codes. And for them to run on a computer, they will need to be translated. After translation, that's when they can run on a computer. So to begin with, there are high-level languages. And the most used type of high-level languages, it's Java nowadays. Java can run on almost any computer which is online on the internet. And what we should know about Java, obviously, as you can see, there are other examples of high-level languages. We've got C++, we've got Python, Perl, we've got Java. There are others which are not on the list. But as per your curriculum, we are going to look at C++ as your programming language. So the main advantage of using high-level languages is that it is easier than any other programs to be understood by human beings. So it is much easier to program in high-level languages. And then the other thing that you need to know about high-level languages is that they are portable. This means it does not mean that they are easier to carry. When we say they are portable in programming, simply means you can easily transfer them from one computer to another. In computer programming, we call that they are machine independent. They can run on any machine. When we say they are machine dependent, it simply means a program needs to be programmed on the very machine it is going to run on. And thereafter, that program cannot be transferred to any other machine. Such a program, we call it as a machine dependent. When we say machine independent, a program can run on any other machine, even on a machine where it was not programmed. And this is the reason why high-level languages have been so very popular of late, because they can run on any machine. And you also need to remember the functions of an interpreter and a compiler. In an interpreter environment, we've got a source code, like from this screenshot, assembly level, this is a source code. So from a source code, we need an interpreter in between there. And the output there will be a machine language. Then in secondary, we need a source code for a high-level language. Then in between there, we need a compiler. After compiling a source code, we have an object code. The difference is, on the interpreter, it is interpreting, no sooner it interprets, it goes to the output. It interprets line by line. When one line is interpreted, it is executed. It's different from compilers. In high-level languages, when a source code is run, first it's supposed to be compiled entirely. After it has been compiled, we've got what we call an object code. The object code is what is going to be executed to run on a computer. So there is the issue of a source file, the original program written by a programmer, which is going to be compiled to come up with the object code. The object code is the one that can be executed on a computer to produce the output. So to fully understand this, I have with me a simple program here written in C++. C++ is a high-level language, and we can use it to write a computer program. So this is a simple program. Any C++ starts with that instruction or statement, and it follows with that instruction. Then the thing that will execute on a computer begins with where it is saying int up to where it is closed. So here we've got C out, hello world. So what this means is that when we run this program, C out is going to print or display hello world on the screen of the computer. Let me show you one pseudocode in practice. So let's try to do this program together. So I have the first statement. The first statement there shows the beginning of a computer program. And it's supposed to be there in any C++ programming language. After you enter those in a compiler for C++, you need also to enter this. There are no explanation for this. As long as you are using C++, they are supposed to be there. And then a function of a program will begin from here. Int menu, then we've got those brackets there. And you've seen these in mathematics for sets. And that's where the entire code of a program is going to be typed in. So I start with int index is equal to 1. So what does that mean? We need to know that index is a variable now. We have given this index a variable and an initialization value of 1. And since it begins with int, it simply means wherever index is going to appear in the running of the program, it's supposed to be an integer. When you enter anything less than an integer, you're going to have a runtime error and the program will crash. In a computer program, you need to tell it what is going to be used inside the source code. So we are saying that index is a variable which is going to store a value 1. In other words, we have assigned the storage index with a value 1. And this storage index is going to be an integer throughout the running of this program. And then we have a loop. We looked at loops in class. While can be used for loops. Else, if, and for. There are also some of the reserved words that we can use when writing a loop in a program. So we are saying while index is less or equal to 5. So this instruction is supposed to be made for a computer to finish its loop. Otherwise, the loop will continue. So while index is less or equal to 5, we are going to be executing this instruction. As long as the program is running and the index is less than or equal to 5, this instruction is going to be executed. So it's saying cout, which simply means print index. So while index is less or equal to 5, we'll continue printing. So the first instruction will run and the output will be 1. Since we're saying that while it's less or equal to 5, it will continue running. So after 1 is printed, it will run again and a 2 will be printed. Since 2 is not meeting the condition given here, index less or equal to 5, the instruction will run again. Why is it going to be running again and again? Because as you see this instruction at the bottom, index plus plus, which simply means this statement will be counting to see to it that this instruction inside there, the function, is met until index is equal to 5. Then a program is going to terminate. So C out index. And what is index? Index is an integer. So it will be printing integers until the integer is equal to 5. Then what follows after the index there, which is saying end line, ensures that after one output is on the screen, the next output should be on the next line. Without this instruction, the output will continue being on the same line continuously. To avoid that confusion, we are going to have this. And then return 0. I know we discussed this one in class. It should be the ending point of any C++ program. So now, let's run this program to see how it is going to be executed. So we go there where it is saying compile and run. When we run, that is compiling. As long as there are no problems, this program will execute. So it's running, 0 errors, and there we are. And it has given us the expected output. So after the first execution, it gave us 1. Since index is still not, this instruction is still not met, that program is going to execute until it meets 5. So while index is less or equal to 5, the instruction is going to be executed until this instruction is met. And that is the reason why the output there, finally it is 5. And that is the end of that execution. And you would be able to see that the program has run to conclusion or completion without errors. So I'll be able to post this video on your Moodle, but I would want you to go through this video, understand this code, source code, before you can attempt the exercise at the end of the notes in your Moodle notes. And I will need to see to it that you've read through the notes before attempting this exercise. So at the bottom there, this is the same program we've been running in a compiler, and it gave us the final execution of 5. So for your exercise, you are going to try to understand the meaning of this source code. And then you write down the expected output down here. Just like we have an output here. You go syntax by syntax, understand the meaning of each and every line in the code before you write down the output. This is the example, this is the exercise. And I hope that has been very informative. See you next time.